So now we are moving on to section 4. In section 4, we're going to start working with the real number system, and we're going to start working with positive and negative numbers. We're going to be doing operations with those and starting to look at how things affect data as they're positive and negative. So if we're going to add two numbers with the same sign, my answer is going to have the sign of the two values, whether they're positive or negative. So 1 plus 4 is 5. We already know that. We don't need the number line explanation. But this is the explanation for approaching this on the number line. Again, don't get confused with that. If I'm adding two values with the same sign, my answer is going to be negative here, and I'm just going to do 2 plus 5 is negative 7. This is a visual explanation for why. Because I'm going 7 units to the left of 0, but you can just remember, same sign, the answer has the sign of those values, and you're going to actually be adding them together. Now, when we are working with subtraction, we're going to see subtraction as a negative value. Okay, this will be a little different. So we could see negative 2 plus negative 4 as negative 2 minus 4, and that would still be considered the same sign under this rule. So again, I'm just adding the values together. My answer is going to be negative. Adding the values together, my answer is going to be negative. Great. When I'm adding two signs, it's great. It's easy. When I have different signs, that's going to be when I start to encounter a problem. So this is 6 and negative 3. They have two different signs. The number line explanation would be this below. My explanation, that probably makes a little bit more sense, is which number has the largest absolute value, 6 or 3? It would be 6. It has the largest absolute value. Because 6 is positive, my answer will be positive. And then you'll treat negative like subtraction. So 6 minus 3 would be 3. That's my explanation, and sometimes students find that a little easier than the very visual approach of the number line. So again, I have negative 2, positive 6. They're two different signs. 6 has the larger absolute value, so I would do 6 minus 2, and that gives me 4. Here, 6 has the largest absolute value, so my answer is going to be negative because that's the sign, and I would do 6 minus 2, and that still gives me 4, so my answer is negative 4. So that's kind of a handy workaround trick that you can use at times. So negative 10 plus 17, 17 is larger. It's going to be a positive answer. 17 minus 10 is going to be 7. Here, negative 1 and 3/8 is the larger number because it's larger than 1. So I'm going to keep that. My sign is going to be negative as an answer, and this would be read as 3/4 minus that, which would be negative 5/8, because negative is seen as subtraction. Larger one's 9.5, 9.5 minus 3.8. The larger one here, well, they're equal. And if I have two opposites, they cancel out. So it's going to be 0. So we're going to use the definition of subtraction. That is, again, going to be on the number line. It is not something that you need to be an expert at. The number line explanation works for some students. It does not work for other students, and that's perfectly fine. So if I'm trying to do 8 minus 3, this is just showing you the movement. I go to 8 on the number line. Minus is a negative, so you move to the left 3. If I have 4 minus 9, 4 minus 9 can be seen as 4 plus negative 9, which we've already learned the rule for. Negative 9 has the larger absolute value, so my answer is negative, and I'm going to do either 4 minus 9 or 9 minus 4. Whatever you're thinking gets you to the right place, but you just have to remember the sign is going to be negative. Negative 8 minus 5. So here is Miss Robinson's hint. I would see minus 5 as negative 5. They have the same sign. So my answer is going to be negative, and I'm going to do 8 plus 5. So seeing subtraction as a negative is very helpful. In B, I have minus negative. That's a double negative. They become a positive. Then I'm going to have the rule for two different signs. 12 is bigger. My answer is positive. 12 minus 8 is 4. Double negative in C becomes plus a positive. If you're not great at adding fractions, pull out that Web 2.0 calculator and it takes you right to here. 7.5 minus 9.2 is the same as 7.5 plus negative 9.2. Negative value has the larger absolute value, so my answer is negative 1.7. And the calculator will be doing these for you, but it's important to understand where the calculator is getting the answer from, because when we start putting X's in the problem, you have to do this by hand and a calculator can't help you. So that's why we're taking the time to look at this. So the uses of the subtraction symbol. It can represent subtraction. It can represent negative numbers. It can also be the additive inverse or the opposite of addition. Those are three purposes for the subtraction symbol. Let's look at the order of operations when we're dealing with integers. That's basically what we're doing here. I still do the brackets first. Negative 1 minus 4 is negative 1 plus negative 4. They have the same sign, so I'm going to combine them and they're going to be negative. Negative 5 minus 2 is the same as negative 5 plus negative 2. They have the same sign, negative 7. Now we have two different signs. 6 is positive, negative 7 is negative. But negative 7 has a larger absolute value, so my answer will be negative. Got a lot going on here, right? I have minus a negative becomes plus a positive. Then I use the rule for two different signs. 1/3 is bigger, so my answer will be positive. If you're not sure how to do the fractions, open Web 2.0. Negative 1 divided by 6 plus 1 divided by 3 will take you straight to this answer. So I get negative 1/12 because it's not two different signs. Subtraction is seen as a negative. The last thing is I created this chart here just to help you out with this. They're going to write the word negative or show -3 when you're dealing with signed numbers. So really nothing is changed in the operation section other than we're actually indicating a negative in the problem. So nothing's really different from 1.2 here. But these are all the different words that we could use to imply addition. And this is just an example. Now remember we have that prepositional phrase, sum of, which means everything behind it is going to go in a grouping symbol. Then I'm going to do 8 plus -3. The sign will be positive. 8 minus 3 is 5. And I get 12. Again, here are all the words possible for subtraction. This is really handy if you want to copy it into your notebook. You can reference it as you're working through the lab. And remember that some of these, when I say less than, it's that reverse situation. 6 less than 5 is really 5 minus 6. But our instinct is typically to say 6 minus 5. If I say 6 less 5, that is actually in order. So you have to watch if it uses the word than. That's when you know to flip it around. And these are just some examples. The difference between -5 and 12. Minus negative becomes plus positive. And I get 7. 2 subtracted from the sum of. So I got grouping. -4 and 4. And subtracted from means we're going in reverse order. Just like you see in the chart over here. Subtracted from. Reverse order. And I get 2. All right, so the most common application in the lab questions is going to be temperature with changes in temperature. The highest Fahrenheit temperature ever recorded was 79 degrees Fahrenheit in Alaska. The lowest was -56. What is the difference? Difference means subtract highest and lowest temperature. Difference according to my chart means I subtract in order. So I get 79 minus -56 becomes plus a positive, and you get 135 degrees. That table is going to be crucial to being successful in the application problems in the lab to make sure you're doing the subtraction in the right order for the words. Now, as I'm looking at data, I can look at sign data here. If I look at this figure and I use a sign number to represent the change from 1995 to 2000, what's happening here is I increased in my students in millions. But if I want to use a sign number, I'm going to look at the change but from 2000 to 1995. and I get 1.02. That's still a signed number, even though I didn't write a positive in front of it. It still qualifies. So don't get confused in those word problems. Some of them might actually be positive, but a positive number is also a signed number.